ABC is an equilateral triangle and CD is the internal bisector of angle C. Now, the moment you read equilateral triangle, you know that all the three angles are equal and it is equal to 60 degrees. CD is the internal bisector of angle C. So CD is basically the angular bisector. Angular bisector, you know, will divide the angle into two equal halves, right? So angle C is 60 degrees because it is an equilateral triangle, and by bisecting it, we'll get 30 degrees in each part, right? Then he says BC is produced to E such that AC equals to CE. Then what is angle AOE? If O is the orthocenter of the triangle ACE. Let's look at this now. ABC is the equilateral triangle. So let's consider this. This is a triangle A, B, and C, right? A, B, and C. Then he says CD is the internal bisector of angle C. CD is the internal bisector of angle C. So angle C, you know that since it is an equilateral triangle, all are 60 degrees. Each angle is 60 degrees here, right? But by dividing angle C into two halves, right? CD is the internal bisector. So we can say this is 60 degrees. Each will be 30 degrees then, right? Actual angle C is 60 degrees. By dividing it into two parts, we get as 30 degrees each. So 30 degrees here, and this is 30 degrees. All right. Now DC is produced to E. DC is produced to E such that AC equals to CE. DC is produced to E such that AC equals to CE. So let us produce DC. See, produce DC, what happens? Extend this line DC. So this is C here, vertex C. I'm just extending DC, right? Let's say we extend it this way. You're getting it? A straight line. DC is produced to E. Let's say this is the point E. This is the point E. Such that AC equals to CE. See, this length AC is equal to CE. Now he's asking us to find out the angle AOE, where O is the orthocenter of triangle ACE. So if you look at it, ACE becomes a triangle now. By joining A with E, we get a triangle here, right? So what did we do? CD was the internal bisector, which was extended up to the point E, and then AC is equal to CE. All right. O is the orthocenter of the triangle ACE. Now the point here is, if you look at it, this angle C, this straight line DCE, will have 180 degrees angle at point C. Yes or no? DCE or DE is a straight line. Yes or no? What is a straight angle? A straight angle is 180 degrees, right? So I can say that the angle at point C here should be 180 degrees, total 180 degrees. But 30 degrees is taken on this side. So what should be the remaining part? 150 degrees. You getting it? 180 degrees minus 30 degrees, which is equal to 150 degrees. So we can say angle ACE. Angle ACE is equal to 180 degrees minus 30 degrees. I'm sure you have followed that point. It comes out to be 150 degrees. So it is 150 degrees. So angle C here is 150 degrees. Now, the other point that we know is these two sides are equal. In the triangle ACE, see, we are talking about triangle ACE. So in triangle ACE, he says AC is equal to CE. AC equals to CE. What does this mean? This means angle A will be equal to angle E. Angle A will be equal to angle E. Angle A, which? Angle A of triangle ACE, which means only this part. And angle E, this part. Getting? So these two angles are equal. Now, you know that sum of all the three angles is 180 degrees. Out of 180 degrees, if 150 is gone here, A plus E should be 30. 30, if you divide into two parts, 15 degrees each. So you can conclude that it will be 15 degrees each. I'm not writing those intermediate steps. I hope you have followed this. Sum of all the angles has to be 180 degrees. We have already got one of the angles as 150. And we also know that the remaining two angles are equal. So 150 plus 15 plus 15 makes it 180 degrees. So we basically know the three angles of the triangle ACE, right? In the triangle ACE, angle C is 150, angle A and angle E are 15 degrees each. And why are these two angles equal? Because the sides have been given as equal. Yes or no? The sides has been given as equal. Now what do we do? He's asking us to find out the angle AOE. Angle AOE, where O is the orthocenter. Now you may be wondering that where is the orthocenter here? Well, orthocenter we would get only when we draw the point of intersection of their altitudes. But one point that you need to remember here is that orthocenter for an obtuse angle triangle will be outside the triangle. See, this ACE triangle is an obtuse angle triangle, right? One of the angles is more than 90 degrees. So orthocenter will be outside the triangle. Let's say this is the orthocenter O. Somewhere, right? Orthocenter O. Now he says find out the angle AOE. So basically we need to measure this angle AOE. What is the angle AOE is the question. Angle AOE. Now going by the properties of orthocenter, you know that angle AOE plus angle ACE should be equal to 180 degrees. Now please don't ask me how, why and all that stuff. This property has been discussed very clearly in this topic of triangle, right? When we were discussing about orthocenter. See, the angle made by any side with the orthocenter and the opposite angle are always supplementary, which means the sum of these two angles will be 180 degrees. We already know that angle ACE is 150 degrees. Substitute it here. In fact, this 15 degrees calculation was not needed. You can directly say that if this is 150, then the angle there will be 30 degrees. Yes or no? This angle will be 30 degrees. So we can say that angle AOE will be equal to 180 degrees minus ACE. What is ACE? 150 degrees. So the answer would be option 3, 30 degrees. Option 3, 30 degrees.